Question 11, proof by contradiction. To prove that root 2 is irrational is in the textbook, right at the start of the year 2 pure textbook. And the proof that root 7 is irrational is very similar. So by irrational, we're trying to show that root 7 cannot be written as a fraction. So let's assume the opposite. Let's assume root 7 is rational. So then root 7 can be written as a fraction. Okay, hopefully something's going to go wrong here, which means the original statement up here must be true. So any rational number can be written as a fraction where you have two integers divided by each other with no common factors. So a and b are positive integers with no common factors, and that is very important. Okay, so let's underline that. So let's square both sides, and we get 7 equals a squared over b squared. That means that a squared is 7b squared, and so a squared is a multiple of 7. Oh, I ran out of space. Multiple of 7, and that means that a is a multiple of 7. How do we know that? Well, it tells us here that we don't need to prove that. So that's why it has that bit in the bracket in the question, because otherwise we should really prove the step from here to here. But we can assume it because it tells us we can in the question. So because a is a multiple of 7, we can let a equal 7 times k, where k is just a positive integer. And then we can sub that back in here. So that means that 7b squared is 7k squared, which is 49k squared. And divide both sides by 7 gives this. And that means that b squared must be a multiple of 7. A multiple of 7. So that means that b is a multiple of 7, like we explained above. And that means that a and b are both multiples of 7, which is a big contradiction because it means they have a common factor of 7. So therefore a and b have a common factor of 7, which is a big contradiction. Okay, it contradicts what we underlined in red there. Therefore, the original statement must be true. So root 7 is irrational. It cannot be written as a fraction.